This lecture is a continued discussion of latent aspect rating analysis. Earlier, we talked about how to solve the problem of LARA in two stages, where we first do segmentation of different aspects, and then we use a latent regression model to learn the aspect ratings and then latent weights. Now, it's also possible to develop a unified generative model for solving this problem. And that is, we not only model the generation of overrating based on text, we also model the generation of text. And so a natural solution would be to use topic model. So given an entity, we can assume there are aspects that are described by word distributions, topics. And then we can use a topic model to model the generation of the review text. We assume the words in the review text are drawn from these distributions in the same way as we assume for a generative model like PLSA. And then we can then plug in the latent regression model to use the text to further predict the overall rating. And that means we first predict the aspect rating and then combine them with aspect weights to predict the overall rating. So this would give us a unified generative model where we model both the generation of text and the overall rating condition on text. So we don't have time to discuss this model in detail, as in many other cases in this part of the course where we discuss the cutting edge topics. But there's a reference site here where you can find more details. So now I'm going to show you some sample results that you can get by using this kind of generative models. First, it's about rating decomposition. So here what you see are the decomposed ratings for 3 hotels that have the same overall rating. So if you just look at the overall rating, you can't really tell much difference between these hotels. But by decomposing these ratings into aspect ratings, we can see some hotels have higher ratings for some dimensions like value, but others might score better in other dimensions like location. And so this can reveal detailed opinions at the aspect level. Now here the ground truth is shown in the parentheses. So this also allows you to see whether the prediction is accurate. It's not always accurate, but it's mostly still reflecting some of the trends. The second result is to compare different reviewers on the same hotel. So the table shows the decomposed ratings for 2 reviewers about the same hotel. Again, their high-level overall ratings are the same. So if you just look at the overall ratings, you don't really get that much information about the difference between the 2 reviews. But after you decompose the ratings, you can see clearly they have high scores on different dimensions. So this shows that the model can reveal differences in opinions of different reviewers, and such a detailed understanding can help us understand better about reviewers and also better about their feedback on the hotel. This is something very interesting because this is in some sense some byproduct. In our problem formulation, we did not really have to do this, but the design of the generative model has this component. And these are sentiment weights for words in different aspects. And you can see the highly weighted words versus the negatively low weighted words here for each of the 4 dimensions: value, rooms, location, and cleanliness. Right? The top words clearly make sense, and the bottom words also make sense. So this shows that with this approach, we can also learn sentiment information directly from the data. Now, this kind of lexicon is very useful because in general, a word like long, let's say, may have different sentiment polarities for different contexts. So if I say the battery life of this laptop is long, then that's positive. But if I say the rebooting time for the laptop is long, that's bad, right? So even for reviews about the same product, laptop, the word long is ambiguous. It could mean positive, it could mean negative. But this kind of lexicon that we can learn by using this kind of generative models can show whether a word is positive for a particular aspect. So this is clearly very useful. And in fact, such a lexicon can be directly used to tag other reviews about hotels or tag comments about the hotels in social media like tweets. And what's also interesting is that since this is almost completely unsupervised, well, assuming that the reviews with overall ratings are available, and then this can allow us to learn from potentially a large amount of data on the internet to reach sentiment lexicon. And here are some results to validate the preference weights. Remember, the model can infer whether a reviewer cares more about service or the price. Now, how do we know whether the inferred weights are correct? And this poses a very difficult challenge for evaluation. Now, here we show some interesting way of evaluating the results. What you see here are the prices of hotels in different cities. And these are the prices of hotels that are favored by different groups of reviewers. The top 10 are the reviewers with the highest inferred value to other aspect ratio. So, for example, value versus location, value versus room, etc. The top 10 are the reviewers that have the highest ratios by this measure. And that means these reviewers tend to put a lot of weight on value as compared with other dimensions. That means they really emphasize on value. The bottom 10, on the other hand, are the reviewers that have the lowest ratio. What does that mean? Well, that means these reviewers have put higher weights on other aspects than value. So those are people that cared about another dimension, and they didn't care so much about the value in some sense, at least as compared with the top 10 group. Now, these ratios are computed based on the inferred weights from the model. So now you can see the average prices of hotels favored by top 10 reviews are indeed much cheaper than those that are favored by the bottom 10. And this provides some indirect way of validating the inferred weights. It just means the weights are not random. They are actually meaningful here. And in comparison with the average price in these three cities, you can actually see the top 10 tend to have below average price, whereas the bottom 10, where they care a lot about other things like service or room condition, tend to have hotels that have higher prices than average. So with these results, we can build a lot of interesting applications. For example, a direct application would be to generate a rated aspect summary. And because of the decomposition, we can now generate the summaries for each aspect, the positive sentences, the negative sentences about each aspect. It's more informative than the original review that has just the overall rating and the review text. Here are some other results about the aspects discovered from reviews with no ratings. These are MP3 reviews, and these results show that the model can discover some interesting aspects commented on low overall ratings versus those high overall ratings. And they care more about different aspects, or they comment more on different aspects. So that can help us discover, for example, consumers' trend in appreciating different features of products. For example, one might have discovered the trend that people tend to like larger screens of cell phones or lightweight of laptop, etc. And such knowledge can be useful for manufacturers to design their next generation of products. Here are some interesting results on analyzing users' rating behavior. So what you see is average weights on different dimensions by different groups of reviewers. And on the left side, you see the weights of reviewers that like the expensive hotels. They gave the expensive hotels 5 stars. And you can see their average weights tend to be more focused on service. And that suggests that people like expensive hotels because of good service. And that's not surprising. That's also another way to validate the inferred weights. But if you look at the right side, where look at the column of 5 stars, these are the reviewers that like the cheaper hotels. And they gave cheaper hotels 5 stars. As we expected, and they put more weight on value, and that's why they like the cheaper hotels. But if you look at the when they didn't like expensive hotels or cheaper hotels, and you see they tended to have more weights on the condition of the room, cleanliness. right? So this shows that by using this model, we can infer some information that's very hard to obtain, even if you read all the reviews. Right? Even if you read all the reviews, it's very hard to infer such preferences or such emphasis. So this is a case where text mining algorithms can go beyond what humans can do to review interesting patterns in the data. And this, of course, can be very useful. We can compare different hotels, compare the opinions from different consumer groups in different locations. And of course, the model is general. It can be applied to any reviews with overall ratings. So this is a very useful technique that can support a lot of text mining applications. Finally, there is also some result on applying this model for personalized ranking or recommendation of entities. So because we can infer the reviewer's weights on different dimensions, we can allow a user to actually say, what do you care about? So for example, I have a query here that shows 90% of the weight should be on value and 10% on others. So that just means I don't care about the other aspects. I just care about getting a cheap hotel. My emphasis is on the value dimension. Now, what we can do with such a query is that we can use reviewers that we believe have a similar preference to recommend hotels for you. How can we know that? Well, we can infer the weights of those reviewers on different aspects. We can find the reviewers whose weights, or more precise, whose inferred weights are similar to yours, and then use those reviewers to recommend the hotels for you. And this is what we call a personalized, or rather query-specific recommendation. Now, the non-personalized recommendation results are shown on the top. And you can see the top results generally have much higher price than the low group. And that's because when reviewers cared more about the value as dictated by this query, and they tend to really have favor low price hotels. So this is yet another application of this technique. It shows that by doing text mining, we can understand the users better. And once we can understand users better, we can serve these users better. So to summarize our discussion of opinion mining in general, this is a very important topic with a lot of applications. And as a task, sentiment analysis can be usually done by using just text categorization, but standard techniques tend not to be enough, and so we need to have enriched feature representation. And we also need to consider the order of those categories, and we'll talk about the ordinal regression for solving this problem. We have also shown that the generative models are powerful for mining latent user preferences. In particular, in the generative model for latent rating regression, we embed some interesting preference information and sentiment weights of words in the model. As a result, we can learn those useful information when fitting the model to the data. Now, most approaches have been proposed and evaluated for product reviews, and that was because in such a context, the opinion holder and opinion target are clear, and they are easy to analyze. And they, of course, also have a lot of practical applications. But opinion mining from news and social media is also important, but that's more difficult than analyzing review data, mainly because the opinion holders and opinion targets are all implicit, and so that calls for natural language processing techniques to uncover them accurately. So here are some suggested readings. The first two are small books that are excellent reviews of this topic, where you can find a lot of discussion about the other variations of the problem and techniques proposed for solving the problem. The next two papers are about the generative models for latent aspect rating analysis. The first one is about solving the problem using two stages, and the second one is about a unified model where a topic model is integrated with the regression model to solve the problem using a unified model.